In this tutorial, I will perform a time frequency analysis. Time frequency from spectrum. This time I want to use a continuous wavelet transform. And then this define what kind of data I want. Like I want to use just a kind of trial. It's good trial, good channel, and image sensor. And I want to select more data. Connect. So we got the time from 15 to 52. And this is a control. I don't need a control. I can get a very nice time frequency data. Now the frequency range from here is 159 to 2000. Probably got sequential too high. I use 2. Now I can 50. Probably I need more data. So it's get a low frequency non-data. As you can see, frequencies get shorter. If you get a 1 sequential, can get a 10. So 2 probably is good. And I will analyze from 20 and to 1000. And for the frequency bands or frequency bins, I want 600. Because this is functional data, so I will use a real time. So other parameters, we do not have to make any change at all. The algorithm is the default. It's real time. Once we click start, now we will start to compute the data. If we now let's switch to, suppose we already finished the computing. See, already done. And we come here. First of all, we can see the topography. To see what's the distribution here. You see, some of the sensory. We got a. This is a left. So this is a right. You just start with R. You select channel. You can select the name MRF means right. To the right, some of the sensor area. We can see the real imaging part. We can see the spectral power. So that's a spectral power. We can hide the label. Just keep the sensors. If we click start moving, and then you can see here the time change, frequency change. So this basically the change of specific colors along the time and the frequency window. And we can also see single trials. As you can see, this is a one channel amount. And we can look through all of them, for example, by using the arrow key, move up and down to see the frequency changes of the real data. And we can use the imaging data. This right side. We can see the power. And also we can go through each channel to see how the spectrum changes. We can see the group, that's with all the sensors. If you think it's not good, you can see the minimum value. Of course, for power is you can see real data, and you can see the maximum value. You can see the positive value, see the minimum negative. can say let's go this. Do some more care. If you want to make a fusion better, you can change this ratio field. You can change the area. So if you now this is a different how we look at it. We can find this. Of course, we can change the scale. Spectral default. And here, use the cursor. You can measure the latency. And here is the frequency. This is the frequency. This is the entire window from 14 to 138. So the time window is from here. So this is a millisecond, 29 to 79. That's a spectral power. You can measure the entire stuff. You can move this back and forward. You can zoom in, zoom out. You can out of it, make the adjustment correct. You can reset, and of course you can hide the selection line. Show information. These are the information. Selection line. You can hide the scroll bar. You see here. The scale bar is gone. Measure here. If you are going to count the exact number of this spectral power, you can click select measure. As you can see, in this group being this minimum, mean, maximum of this. If you want to, like, you can copy this, use a Control C, and you can paste it to the Excel. Suppose we have an Excel file, you can just Control paste, just put a wizard. Next, see, you got all those spectral data here, and for statistical analysis, very easy. You can get all the channels. If you click this one, basically they just use those parameters here, this, and measure them. You see, design the same. With this one, you get all the channels, statistical analysis. And if you don't need those information, and you can reset the data, everything is gone. Data info, you can click here. And then if we click the all spectrum, that's we take a time. Basically this is all the data of the group over here, all this group. You can copy paste all those data to Excel file as well. So this is single trial. If you want to update the group, for example, update, you can just use the uncheck this, and check this one, visible. You can by change the visibility. Let's uncheck this, and click OK, and then we recalculate the group. Recalculate the group means. Basically, they recalculate the group means. Recalculate group mean minimum, maximum power. So Regarding the visibility of the channels, typically we adjust from here. Select the channel, click the right mouse, visibility, go to channel, right channel. You can hide the channel. So this is the spectral power. You can also look at the 3D field. So this is just another way to look at the data. And this is both contour map. You can see once you start contour maps of the data. You can highlight the label, highlight this. Out of it. Okay, select, refresh. So see, this is correct, but this is time frequency. It's time frequency. Just the data. We can also see the 3D. Sensor. Contour maps. Contour map. You can also see single channels. If you think it's too big, shrink a little bit. Maximum, that's maximum value. Image data. Power. If you can refresh. This one to change it. some of the sensory spectrogram in 3D. Looks like this.